Hello, it's Megan from the Math Workshop. Welcome to this video on using pattern blocks. Pattern blocks are one of our very favorite math manipulatives or math tools that can be used with students from year 4-year-olds through teens to make sense of abstract math concepts. In this video, we will explore the what, the why, the how, and when we can use pattern blocks. Pattern blocks were created in 1963 as part of the elementary science study at the Education Development Center in Massachusetts, according to Wikipedia. And the goal was to develop hands-on learning tools for math and science education. Some educational companies produce them in a plastic form, and others produce them in a foam form. One of the first experiences we want to provide for our students is, of course, the opportunity to explore pattern blocks, touching them, turning them around, stacking them, starting to notice their attributes. Early on, we want to provide labels like names to the pattern blocks so that we can have a common language to talk about them and identify them. This is our first activity card in our pattern block kit 1. Do these names line up with what you're thinking? The names are pretty straightforward, right? Except for a few things. Notice the blue shape? Lots of preschoolers might call the blue shape a diamond. Actually, mathematicians do not recognize the word diamond as a mathematical shape. So we recommend sharing the actual name with students as early as possible. Why not? Let's empower them. In fact, in the math standards for elementary school, you will not find the word diamond. Is there anything else interesting about that blue shape for you? If you've used pattern blocks in the past, you might have called the blue shape a rhombus. And you were correct. It is a rhombus. Just like the last shape on the slide, the tan rhombus. They are both rhombuses. And incidentally, I did Google that. It is not rhombi, it's rhombuses. They're also both polygons. Well, all the shapes on this slide are polygons. They have at least 3 sides and they're closed shapes. The blue shape and the tan shape are also both quadrilaterals, as well as the orange square and the red trapezoid, meaning they have 4 sides. The reason we chose to use the label of parallelogram for the blue shape is to help delineate it from the tan shape. But it's important to discuss with students that yes, the blue and the tan shape are both parallelograms, meaning they both have 2 sets of parallel sides. They are also both polygons as well as quadrilaterals. And they're both rhombuses. Do you remember the rule for being in the rhombus club? Here's a hint. The orange square also belongs to the rhombus club. Rhombuses have all sides of equal length. How come the blue and the tan shape don't get to be in the square club? The square club is special. Do you remember why? To be in the square club, you have to have 4 equal length sides, which the blue and the tan shape do have. But you also have to have 4 right angles, which they don't. The blue and the tan shape both have 2 acute angles and 2 obtuse angles. And depending on the age of students you're working with, that's going to depend on how specific you're going to get with these attributes and these characteristics. Why provide opportunities for your students or your children to use pattern blocks? Because pattern blocks are such a valuable math manipulative to use with our students to teach a variety of concepts in a hands-on, visual, and tactile way. They're particularly useful for developing understanding of geometric shapes, fractions, symmetry, patterns, and spatial reasoning. We're going to share with you examples of how this one tool of the pattern block can be used in so many different ways from preschool through middle school. But before we explore those tons of ways to use pattern blocks with students, let's pause for a moment and talk. Have you heard about CRA in math before? Does it sound familiar? What do you recall? CRA stands for concrete, representation, and abstract. This model has its roots in the work of psychologist Jerome Bruner. Bruner's theory of cognitive development, specifically his stages of representation, heavily influenced the development of the CRA approach. The CRA model is a three-stage learning process where students first experience concepts with concrete objects, then move to pictorial representations, and finally to abstract symbolic notation. That's using numbers and symbols, equations, greater than, less than, all of that. While Bruner's ideas laid the foundation, the CRA model was further developed and popularized in the 1980s, with Singapore's Ministry of Education adopting it as a key teaching strategy. Here's a visual image to help us think more about the CRA approach. Notice that concrete level is at the bottom. It's the largest level. It's laying the foundation for further learning. So for example, we're looking at multiplication on the left part of the slide. We're looking at addition on the right-hand part. And we're seeing examples of objects on the bottom. Students would be manipulating with their hands, tactile, hands-on, to really understand those operations of multiplication and addition. Then we can move students to sketching a picture or a drawing to represent their thinking because they've already done it with the real object. Then they can transfer that learning to the abstract level using numbers and using numbers and symbols. Here's the problem. For some students like myself, when I was in elementary school, I was only provided that top level abstract symbols. I think that's what was popular at the time. I don't blame my teachers. I had wonderful teachers. But I don't remember having my hands on any tools at all. And so for me, I struggled in math class. I tried to do my best memorizing facts and trying to memorize different standard algorithms for multiplication, division, but honestly, I made a lot of mistakes and if I forgot a fact that I had memorized, I had no idea how to even figure it out because I didn't have that underlying conceptual understanding of what was going on that I needed. Now, maybe you say not everybody's like me, and that could be true. And some kids just seem really inherently able to just grasp abstract symbols and equations and numbers and be able to work with them. But it's interesting. Sometimes with those particular students, we ask them, well, hey, can you show me with this model what that looks like? Maybe it's a division problem and it's in third grade. Can you show me what 32 divided by 8 looks like with this model? And sometimes those students aren't able to do it. So there has been interesting research which has shown that the more ways we can understand a mathematical concept, the deeper our understanding is. Let's look at one more model before we move on to our pattern block examples. This one's called the Lesch model, and it's related to the CRA model because the Lesch model, it's known as the Lesch translation model. It originated from the work of Richard Lesch in 1979. And it has to do with this framework in mathematics education focused on the importance of understanding mathematical ideas through multiple representations and the ability to translate back and forth between them. I'm sure you notice you see arrows going multiple ways on the slide. So instead of the CRA, where the idea was first we start with concrete, then representational, and then abstract, this model, it is related, but it's a little bit different. And here's how it's different. We see the concrete in the pink. That's the C in the CRA model. We see the visual in the orange. That's R in the CRA model. That's representational, visual, the drawing, the sketch. And the yellow circle, that's the abstract level. That's the symbolic numbers, symbols, um, but what's different about the Lesh model, which I really do like, we also have the green circle and the blue circle. So the green circle, verbal, that's having students explain their thinking, justifying their solutions, listening to another student's strategy and seeing if they can unpack it and understand it. So it's about that communication. Then we have the blue circle, that's contextual. This is really important too. That contextual model, that is related to word problems, story problems, real life examples in a real world context. So here's an example for contextual, the blue circle. If I wanted to share 36 cupcakes among 3 classes, how many cupcakes would each class receive? So then students are asked to really consider the context. Those kinds of problems, especially if there's a remainder left over, can be really important because what do you do with that remainder? It depends on the context. And of course, we want students to grow up to be awesome problem solvers and critical thinkers. So the context is very important. Okay, let's pause for one more moment and let's just take a breath and let's be honest with ourselves. Most of us probably did not learn mathematics in elementary school with many tools. I know I just shared, I don't even remember one tool at all. Okay. So I shared my story. But today's math standards call for students to blend procedural knowledge. That's how I learned. Maybe you too. That's performing steps or procedures and algorithms. But here's the difference about today's standards. It says students will learn procedurally with a balance or a blend of conceptual understanding. That's the C and the R in the CRA level or model, the conceptual, the concrete and the representational. That's being able to make sense of the concepts behind the operations. So I'm curious, did you learn mathematics with a blend of procedural and conceptual? I'm a firm believer that math tools can unlock abstract math concepts for most students because they provide a visual, hands-on, kinesthetic approach to understanding the math standards. I think we have to be honest with ourselves for most of us. We're asked to teach math in a way that is different than we were taught. I am ecstatic about this, but I recognize that it's a journey for us as educators and parents, and we need to be patient with ourselves as we learn multiple math tools, manipulatives, and representations that can support our learning and further our learning, but most importantly, help us support our students' mathematical understanding. All right, let's begin exploring the many different concepts that can be taught and modeled and represented through the use of pattern blocks. So let's get into it. The how. We recommend starting with students grabbing a handful of pattern blocks and sorting them. Sorting them by shape. You could also say it's sorting by color, which is going to end up to be the same thing, and having them count and write how many they have of each shape. Then we could ask them to find the total number. So we're going to start, of course, in preschool with a very, very small amount, but we can increase over time. You notice the image over in the small image on the right-hand side of the screen. We recommend in our kits where we have these activity cards, so they're printed on cardstock, to place them inside plastic sleeves with and provide dry erase pens for students. So in our kits, we have plastic sleeves and dry erase pens. So then the cards can be used multiple times by multiple students. Next up, presenting some design cards to students, seeing if they can replicate, they can actually place the shapes. Are they recognizing the shapes? Can they place it on top? What does it look like? Naming the shapes, naming the colors. And here's a higher order thinking. How are these two designs similar and how are they different? Next up, grabbing handful of blocks, again, sorting them, making stacks of the shapes, similar shapes. How many do you have in each stack? Which stack has the most? Look at this next question. This is a hard one for preschool students and kindergartners. How many more does a taller stack have than another stack? How do you know? And a strategy we use a lot with students is lining them up, matching them, and seeing what the leftover are. And that's how many more. Then we've got some graphing. This is a little bit more sophisticated, coloring a portion of the graph for each of the shapes you have, comparing the different categories, how many more, which one has the most, which one has the least. You could even do some comparison, like if I put the trapezoids and the squares together, how many is that, and so on. There's so much we can get out of this. Then we have this wonderful tool that we use in preschool and in kindergarten called the 10 frame. This is a 10 frame. And it's a wonderful representation to really get our kids strong with that idea of 10. So we really want kids to leave kindergarten knowing, because they've had so many experiences, knowing that 5 and 5 is 10, 3 and 7 is 10, 2 and 8 is 10, 6 and 4, 9 and 1, 10 and 0, because they've had so many different opportunities. Why is that important? Because that understanding, because of our base 10 system, if I know 3 and 7 is 10, I know 30 and 70 is 100. I know 300 and 700 is 1,000. I know that 3/10 and 7/10 equals one whole. Next up, oh, we have some games in our kit. So using spinners or dice and different games with this one has to do with addition, using the double 10 frames. So now we're moving up to 20. These are different players' cards. We have spinner cards. And I love this because we have two different spinner cards, letting students make a choice. So the winner is the person who fills their design card first, and I'll share those with you in just a second. But you'll notice not all of these spinner cards have equal representation of the 6 shapes, and there are 6 sections intentionally. I wouldn't tell students this though. Let them discover this. So just eyeball the different spinners for a moment. And then here's an example of a design card. So the idea is if you're using this as a game, you let the student choose the spinner card they want to use, and they spin and try to fill in their design card. Now, just between you and me, if this is a design card you chose, of course, you want to make sure you have a spinner that has hexagons, parallelogram, and triangle. But again, don't tell your student or your children that. Let them discover that through the use of play. So a little bit of probability in there. So you're going to have activity cards that are introducing sides and vertices. That is in the kindergarten standards. sorting shapes by name, by color, by number of sides, by number of vertices. Some more design cards. There's going to be lots of design cards. Oh, we love this activity. Place with a partner. One of you secretly places one of the pattern blocks inside the bag, and this is included in your kit, and have the other partner, without looking inside the bag, put their hand in and guess the shape based on its attributes, based on how it feels. They can say out loud what shape they think it is. And then they may look in the bag and see if they were correct. And they can take turns. So we're really getting them to think about the attributes of that shape. This is another fun one, still using the brown bag. So you have player A fill the 10 frame with 10 pattern blocks. It doesn't matter what they are, it just matters that there's 10. So there's one pattern block in each of the squares in the 10 frame. Then player A needs to turn around or leave the room or not look. And player B is going to secretly remove, without player A seeing, some of the pattern blocks from the 10 frame. So some are going to be left, and the ones that are removed are going to be put inside the brown bag. Then player A turns back around and guesses how many are in the bag using the information of how many are still on the 10 frame. So this is really helping them again with ways to make 10. And they can write if they're ready. I wouldn't do this initially, but after we've done this a while, then they could write the corresponding addition equation, or you could think of it as subtraction based on what was missing. Really powerful experience for our young students. Then we have, you can do work with repeating pattern, another repeating pattern, another repeating pattern, and then we have a growing pattern. So if you add a layer below, how is the pattern growing? So much you can do with patterning. We love this one. This one's really different. So we ask students to, we just imagine that is a giraffe. You see his parallel legs. You see his body, his neck, and his head. And so they could just put the tan rhombuses on top of the design. And we ask students, can you create the same design, the same giraffe, in a different direction, but you can only move one tan rhombus. That's all you can move. And in our activity kits, in our pattern block kits, we have an answer key. This one is really challenging, but a lot of fun. Then we have guess my rule. Oh, we can do so much with guess my rule and pattern blocks. So secretly make a rule. I recommend students write it down somewhere because sometimes those little rascals change their rule and it messes up everything. And they have a partner say, well, does a circle fit the rule? And partner A then would say yes or no. If the shape fits the rule, it goes inside the circle. So it's a real good visual, place it in there. If it doesn't fit the rule, it goes outside the circle. And that partner B is trying to guess what the rule is. So rules could be things like shapes with 3 sides only. It could be yellow shapes. It could be shapes that have 2 parallel lines, sets of 2 parallel lines. So it's really dependent on the age of the child and where they are in their learning. More design cards, lots of design cards. Here's another one of that higher level thinking. How are they similar? How are they different? Then we're moving into addition. So you're always going to see in our kit that the cards, first there's going to be a little bit of teaching, and then there'll be examples. And I see this is not portrayed. I see it's kind of, the lines are messed up, but with our cards, they are correct. It's just, I see down at the bottom where the equation is, the way it's displayed in a PowerPoint isn't displaying as nicely as it looks on the cards. But you get the idea. More design cards, lots of design cards. Now we're asking students to write an addition equation based on, might be adding that you could have them add the number of squares with the number of rhombuses or the number of triangles. It's really open-ended. More design cards. Now we're introducing line of symmetry. So this first card has what a line of symmetry is. Then we're asking students later, comes up later, to make a reflection of the design across a line of symmetry. So many, there's lots of those. Now we're moving into subtraction. So if we put all the trapezoids and parallelograms together, get a total there, and the triangles and the rhombuses together, and we subtract those two groups, what would our answer be? So more design cards. Here's a creative one. Create your own design and name it. How many of each shape did you use? What was your total? Another guess my rule, but using a Venn diagram, so it's a little more sophisticated. Then we've got some complete the symmetrical mirror of the design. Notice this one does not have the tracing of the lines, and this one does. Create half of the symmetrical design and have someone else finish the other half, or the child could finish the other half. Now we're getting into second grade, partitioning pattern blocks. This is a second grade standard. It's actually laying the foundation for fractions. And so we could put this in a plastic sleeve and have students use the dry erase pen to first show the halves on each of the shapes and then erase that. Thirds, so partitioning, and that's a very specific word that's in the standards. Partitioning by thirds, and then erase those, and then partition by fourths. Then we start, this is another second grade standard. We're laying the foundation for multiplication that's going to be introduced in third grade, but multiplication is really repeated addition. So in second grade, students are asked to create arrays to match addition equations. So on the slide, we see using the squares, 2 rows of 3. And that language is really important in second grade because that is going to support, again, multiplication. So 3 plus 3. So having students show their own models for show and solve for the problems on the bottom. Write a matching addition equation for this array. What do you think it would be? Did you say 4 plus 4? Or if we rotated the image, could say 2 plus 2 plus 2 plus 2. Same thing for this one. So we have several examples. Okay. Then we have show and solve. We have the repeated addition, some of it, most of it, until the bottom. And we're asking students, do you see the bottom question? What do all of these arrays have in common? Again, they're using their pattern blocks. And oh, this one's not displaying that well either on the top, but our card doesn't look like this. It does. It prints out beautifully. It's just something to do with the PowerPoint being in presentation mode, throws it off. But this is another example. So providing that support of what even numbers are over on the right-hand side, and how we explain this to second graders in a conceptual way is that even numbers always have partners. And odd numbers, there's going to be one left over. So it's a real conceptual way to understand even and odd numbers. Later, students will make that leap that if there's a 0, a 2, a 4, a 6, or an 8 in the ones place, it is even. We don't want to teach them that initially. They're going to move to that. But again, this is about layers, that if we build that foundation first, they're much more likely to remember those kinds of statements. Like if there's a 0, 2, 4, 6, or 8 in the ones place, it's even. We have an even or odd game. All right, now we are moving into grade 3 through 7 content. So now we're building on, so you can use examples like this in third grade. We're building on what we did in second grade, But now we've moved on to multiplication. So 2 rows of 3, 2 times 3 is 6. All right, same kinds of examples as before, but multiplication. These are probably some of our favorite slides because these are so powerful. We know as math educators that the properties of operations for multiplication are the core to understanding multiplication. So we have examples of all the properties. This is the identity property, the product of any number, and 1 is that number. Now we can tell kids that. And I think I probably learned these in middle school, but I didn't have an understanding of what it was. Because if we're just telling them, most people don't remember what was told to them. So the properties of operations do show up in elementary school standards. And it's not so important that kids memorize the name. That's not what it's about. What it's about is really understanding the concept. So in this one, if we really understand that anytime we have a number times 1, it's that number. This picture really shows that. The picture is showing 3 groups of 1. 3 groups of 1. Or we could have 1 group of 3, and that would be 1 circle with 3 triangles in it. 1 group of 3. So again, we're really understanding the language. Here's another one, the 0 property. The example you're looking at is 3 groups. That's the 3 circles, 3 groups with nothing in them. There's nothing. And I couldn't do an example of 0 groups of 3 because there's no groups. So just flipping them. Oh, the distributive property, probably my favorite property. I wish I had known this when I was in 3rd grade trying to memorize my facts, because this property is saying if I forget, for example, 7 times 7, it's okay. If I understand the distributive property and I know 3 times 7 and 4 times 7, because I just broke apart one of those 7s into a 3 and a 4, I can very quickly find the product. So 3 times 7 is 21, 4 times 7 is 28. Add those products together, I've got 49. So though it is nice to know my facts and memorize my facts so I can move on and do higher level mathematics and not be sitting in 11th grade trying to figure out the answer, but realistically, even myself as an adult, occasionally I forget my multiplication facts. But if I have a quick and efficient way to get to the answer because I really understand multiplication, it takes me 5 seconds. So it's not that big of a deal. That's what we want our students to be, really flexible in their thinking. In case they forget a fact, they can get there quickly. Another example, commutative property. 2 times 3 is the same thing as 3 times 2. There's still 6. The order of the factors doesn't matter. So having students use pattern blocks to model these big ideas. And the last one, the associative property, a little more challenging for most students to get their heads around. They just need time. And then we have some games we can play with our pattern blocks. This one's supporting multiplication. Then we can talk about division. So there are 2 models for division, the fair sharing strategy. In that strategy, you're figuring out how many were in each group. And then the grouping strategy, you're figuring out how many groups were there. Then we have matching division equations with arrays and so on. Now we're moving into fractions. Oh my goodness, pattern blocks are so amazing for helping us really understand the abstract concept of fractions. So students they can choose to use this spinner or this spinner. And they use the spinner. This is player A's card and player B card. And the person who fills their 4 hexagon first wins. Oh, we had C and D too. Another multiplication game. Oh, we love these slides. We can do so much work with understanding fractions with pattern blocks. So this is just an introduction, and this is not fractions, but we're just getting kids thinking about if figure 1 is equal to 1 whole, how much is figure 2? It's 1 whole too. So we're just kind of just getting warmed up. What are we talking about here? Now, the next slide. So these are all in sequence. If figure 1 is equal to 1 whole, how much is figure 2? And we would recommend, of course, students have the pattern blocks on their desk and they are figuring it out. And they're going to figure out that 6 of the triangles fit perfectly on top of that yellow hexagon. So again, this is not a fraction 1 yet. We're warming up. But if figure 1 is 1, figure 2 is equal to 6. So we have a couple of these, just getting kids considering the relationship between the two figures. Then we move on. So we're not in fractions yet. This one's saying if figure 1 is 1 whole, how much is figure 2? We're still with 1 whole. Now, when do we start? We start right here. If figure 1 is equal to 1 whole, how much is figure 2? It's 1/2 because it's half of what is in figure 1. And so the rest of these have to do with fractions. And again, we in our kits, we have answer keys for teachers and educators. And again, we really recommend that students have their hands on these and justifying and reasoning what they think the solution is and why. And look at this one. Figure 1 is if figure 1 is equal to 1/2, and we're allowed to be flexible like this. How much is figure 2? How do you know? These are really good. And then you see on the bottom for a challenge could be interpreted with fractions, decimals, or percents. You can really push yourself. Oh, we love these too. Figure 1 is equal to 1 whole. How much is figure 2? So again, having our hands on the tools to make sense. What is so powerful about pattern blocks and fractions is that there is a direct relationship to all of the shapes that you see on the slide right now and the blue parallelogram. You are not going to see the tan rhombus or the orange square in any of these images because for whatever reason, and I don't know the answer, but for whatever reason, they don't match up that we could figure out the area and its relationship. It's not as easy. Maybe if we had really, really, really small grid paper, we could trace them and figure it out, but it's not innate and it's not, we're not going to be using it in elementary school. So at this point, we kind of just leave the square and the tan rhombus to the side, but we use the rest of the shapes. And then we can start adding fractions using our models. We can talk about equivalent fractions. What I love about this work, I'm gonna be quiet for a moment and let you look at this slide. Oh, it's not all displaying that well. It looks different, I see, when I print it, but you're gonna get the general idea. Part of it is not on there. For some weird reason in presentation mode, it looks different. What's so beautiful to me about this is the whole is changing, but we can still consider the relationship between the whole to its parts to talk about equivalent fractions. Then we can add fractions using pattern blocks. We can subtract fractions. We do have to be strategic in the choice of our denominators so that it works out that the relationship between the pattern blocks is going to work out. So we've done the work for you in our kits. These all work out. Students are able to use the manipulative to solve these. And then eventually, of course, they're not going to be sitting probably in college using pattern blocks, but it's okay. They really understand subtracting fractions. So later in life, they will remember their experiences and they will have internalized the operations that they can just move to abstract, just using the numbers and the symbols. You can even multiply fractions using pattern blocks. Oh, I love this example. Do you see the three groups of 2/3? Three groups of 2/3 is equal to 6/3, which is equal to 2. If we put those 6 blue parallelograms all together and envision them on top of those 2 yellow hexagons, you would see that it was 2. It represents 2. So again, we have an answer key. And again, we chose numbers and denominators that are going to work out with the pattern blocks. You can even divide fractions. Oh, I'm sorry. I said that too quickly. That's the next slide. Multiplying fractions example. This was before we had a whole number by a fraction. Now we have fraction by fraction. Then we have division. Look at that. In 3 groups, so 3 divided by half. In 3, I said that wrong, not 3 groups. In 3, how many groups of a half or how many halves are there in 3? This visual really shows that. We can see in 3, the whole number of just 3, there are 6 groups or 6 1/2s. Again, we strategically chose numbers that are going to work out beautifully with showing this conceptual idea of dividing a whole number by a fraction. And again, it's just laying that groundwork for students to be successful later when they're just using abstract and just solving. Then we move into ratios. What is the ratio of hexagons? So how many hexagons to how many blue parallelograms? And we can ask students to also consider the fractional relationship, the decimal relationship, and the percent relationship. And we ask students if the ratios can be simplified, go ahead and do that. They start out kind of simple and then they get a little more, just, I wouldn't say hard, but a little more interesting. Then we have a ratio game. And again, then they're going to move on to that abstract level later, away from the manipulative, but they will have had this real understanding of ratios. All right, we are wrapping up. So when should we use pattern blocks or any other math manipulative? We recommend at the beginning of the time that your students or your children are learning a math concept, whatever it is. Remember that CRA model that's used in math education? So the manipulative can be that concrete representation of that operation or that big idea. And then ask students after a while, after they really seem to have grasped the idea, then they can move to sketching or drawings that are in the representational. And then later you're just going to move to abstract. When to use pattern blocks? Boy, you can do it anytime. Whole group time, small group time, one-on-one. You can put them in math centers with different kinds of activities like you're seeing from our kits. So let's wrap up. Oh, goodness. Thank you for all you're doing for your students and your children. We wanted to share that on our website. Excuse me. We have 3 different kits where we have done the work for you. Pattern Block Kit 1 covers the content that I showed you from preschool, pre-K through 2nd grade. So it goes all the way up to even and odd numbers. The second kit covers the content from third grade, so starting with multiplication, going all the way up to seventh grade. So those were the ratio slides we saw at the end. Both kit 1 and 2 have over 60 cards. They have the plastic sleeves, dry erase pens, they have dice, paper clips, and they have over 100 pattern blocks in the kit. And of course, if you are a classroom teacher, you can order more of the pattern blocks or use the ones that we provided for you and put it in a math center. Additionally, we have a complete kit. This is great for teachers that might be working with multi-level students or have students that have a wide range of skills. Or it could also be great for families that have multiple age children, or they really want their child to have the kit and grow along with it. Because in the complete kit, you get everything, all over 120 cards. And again, that's activity cards, game cards, design cards. And you still get over 100 pattern blocks and the plastic sleeves and the dry erase pens and the dice and the paper clips for using with the spinners. So you can learn more about that at our store at themathworkshop.net. Thank you so much for your time. Again, thank you for what you do for your children and your students. And we just hope you have a wonderful year of learning. See you next time.